Good day. We're carrying on with the density notes. We've talked about what density means and the units of density and why some things are denser than others. And now we're going to look at the mass of density and calculations related to it. So we have this triangle formula. But in fact, in the old days, we made students memorize the formulas. But nowadays, formulas are provided. So we simply have to know what these things mean. So mass is going to be measured in grams for the most part, sometimes kilograms, but usually in this game grams, with a symbol little g. Density is measured in grams per milliliter or grams per centimeter cubed. And volume is going to be measured in centimeters cubed or milliliters. And the bigger the number we get for density, the more dense the material is, the more mass it has packed in a given volume. And this merely comes back in exactly the same as it was for no real reason. So, there are three kinds of calculations we'll do. You'll be asked to find mass, you'll be asked to find density, you'll be asked to find volume. So we have to get used to these formulas. If we want the mass, it's going to be density times volume. If we want the density, it's going to be mass divided by volume. And if we want the volume, it's going to be mass divided by density. So these are going to be word problems. All it means is you read the question and figure out, am I after mass, density, or volume? And you have the reminders right here. Question wants mass, there's our formula. Question wants density, there's our formula. Question wants volume, there's our formula. So here are the steps. You must show your work. So you read the question and figure out what you find. Then you write out the formula for the equation that'll allow you to get there. Then you plug in the numbers and solve, and you report the answer with the proper units. So we're going to show you a number of examples here of each type of question. So it says, what's the mass of 500 mils of aluminum? Now, right there it says mass. So M equals D times V. 500 milliliters is our volume. We're not given a density, so we go to our periodic table, look up aluminum. So any element on the periodic table, we can get the density from the periodic table. We write down our formula. We write our numbers in. The 2.70 grams per milliliter was found on the periodic table for aluminum. We do our multiplying, our answer will come out in grams. And that's how you're expected to show it. Formula, substitute numbers, answer with proper units. Looks pretty easy, because it is. Now, we're told this is an element. We're told we have a mass of 800 grams and a volume of 516 milliliters. It says we're after density, so we have to put in our density formula. Then we just simply have to plug in our numbers. We have to recognize this is a mass, this is a volume. And we let our calculator do the work. We can see it's going to be somewhere between 1 and 2, because 800 is bigger than 516, but it's not twice as big. It says 1.55 grams per milliliter. It says element, that means we can go to our periodic table and identify it, and that's part B. Part B says, hey, what's the material? So we look at the periodic table, we look for 1.55 grams per milliliter, and we find calcium. So that's a very common type of question you'll be asked. It had the extra step of using the density to identify an unknown material. Third type of question means find the volume. So it can say what volume, it can say how much space is taken up, and all this stuff. Again, we have 2,500 grams, so we know that's mass. We don't have a density. So we say, okay, how are we going to attack this? Well, first of all, we go V equals M divided by D. Lead, the density is not given in the question, density is given on the periodic table. So we look at that, we plug in our numbers. Now, if this is 2,500 divided by 10, our answer would be 250. We're dividing by a number that's bigger than 10, so our answer has to be slightly smaller than 250. So you let your calculator do the work, but it's a good idea to estimate. And we see 219, which is a bit smaller than 250. And that's it. That's how you do the calculations. So review this video. If things aren't making sense, make sure you have all the notes filled in for this particular PowerPoint. And we're going to do more examples in upcoming videos. How to deal with density calculations.